Alright, in the last lecture we have learned different types of binary tree. In this lecture, let's see how can we create a binary tree. A binary tree can be represented in two ways. The first way is using linked list and the second way is using array over here. Now in this course, we will look at both cases and we will implement them in practice. So let's see how a binary tree can be represented in terms of linked list and array over here. So first, we are going to see how can we represent a tree in terms of linked list. So let's say we have a binary tree like this and we want to represent this binary tree in terms of linked list. So the binary tree will look like this via linked list in this case. So we always create a node which will have three components in it. So the first component will be the data, the second component will be left pointer, and the third component will be right pointer. So it's obvious that the data will be the value of the node and the left pointer will point to the address of the left child and the right pointer will point to the physical address of the right child. Now here you can easily see that in drinks, which is a root node in this case, we have two pointers over here. The left pointer points to the physical location of the left child. In our case, left child is hot and the physical location of this child is 222. So in the left pointer we have 222 over here, and in the right pointer we have 333, which is physical location of right child. So in our case, right child is cold and physical location of right child is 333 over here. So that's why on the right pointer we have 333 over here. Now if we continue to this node over here, in this node we have two children also. In this case, hot has children of tea and coffee. So the physical location of T node in this case is 444, so that's why on the left pointer of hot we have 444, and the physical location of right child, which is coffee, is 555. That's why in hot at the right we have 555 over here. Now when you go down, you can see that leaf nodes pointers are null. So in this case, T and coffee do not have any child. That's why left and right pointer of these nodes over here are null. And similarly, the same logic is applicable over here. In the cold, we have cola as a left child and Fanta as a right child. So you can see that in the left pointer of cold, we have 666, which is physical location of cola. And in the right pointer, we have 777, which is physical location of Fanta node over here. And similarly, these nodes, left and right pointers are null because these are leaf nodes, so they don't have any child in this case. So this is how we can represent a tree using linked list. Now let's continue to see how can we represent a binary tree using array over here. So here we have the same tree and we want to implement it using array. The way that it looks, it will be different than the linked list because here we have to save these nodes inside cells in the array. Now the first thing that we are going to do over here, we are going to initialize array with fixed size. So here we have an array of 9 cells. Now in this case, we are not going to use 0th cell over here. The cell which is located at the 0th index, we are not going to use them. The reason for not using this, because in this case, the mathematical complexity becomes very complex. So by leaving this empty and continue with other cells, make mathematical calculations very easier. So that's why I'm skipping the first cell over here. Then I'm going to calculate the indexes and insert these nodes in these indexes over here. So after skipping first node, we are going to use two simple mathematical formulas which will be calculated left and right trees indexes in this case. Now for left tree, it's going to be cell 2x and for right child, it's going to be cell 2x plus 1. Now here, x is the index of given child's parent. Now in this case, first we are going to insert root node at the index of 1. So in our case, root node is drink, so we are going to insert root node at the index of 1. So root node always stays at the index of 1. Then we are going to calculate left and right child's indexes in this case. Now in this case, the left child is hot and the right child is cold. So based on this equation, we have to multiply left child's parent with 2 and we are going to get the index of left child. Now in this case, left child's parent is located at the index of 1, which is drinks. So in this case, if I multiply 2 with 1, in this case I will get 2. So this means that left child will be located at the index of 2 in this case. So we are going to insert left child at the index of 2. Similarly, based on parent's index, we are going to calculate right child's index. So in this case, we are going to multiply with 1 with 2 and plus 1. In this case, we are going to get 3. So this means that right child, in our case, which is cold, is going to insert it at the index of 3 over here. Now then, we are going to calculate indexes of these left and right child's children So in this case, it's going to be like this. So we are going to continue from the left-right subtree. So in this case, in the left-right subtree, we have hot, and for hot, we have two children over here, tea and coffee. So to calculate t's index, in this case, we are going to take the parent of t. So in this case, parent of t, which is located at the index of 2. So we are going to multiply it with 2, then we are getting the index of t in this case. So 4 will be the index of t, so that's why we are going to insert t at the index of 4 over here. Now similarly, we are going to calculate index of coffee over here. So this is right child, so this means that we are going to use this formula over here. So the parent of this coffee is located at the index of 2, which is hot. So we are going to multiply 2 by 2 and plus 2, we are going to get index of 5. So this means that coffee will be inserted at the index of 5 over here. Now similarly, we are going to do the same operation for right subtree, which is cold. So right subtree also has two children in this case. So this means that we are going to calculate them using this formula. So for left child, we are going to calculate using this formula. We have to multiply parent's index with 2. So parent is located at the index of 3. So 3 multiplied by 2 is going to be 6. So this means that we can insert non-alcoholic drinks, which is left child of coal, at the index of 6. Then we are going to calculate the index of right child. So in this case, right child is alcoholic. So this means that we are going to take right child's parent's index, which is cold, which is located at the index of 3, multiplied by 2 and plus 2. So in this case, if we do this calculation, we are getting 7. So this means that this child over here will be located at the index of 7 in this case. Now with this, we have successfully represented this tree in terms of array over here. So by using these formulas over here, we can easily calculate the indexes of left and right subtrees and their children's, and we can easily insert them in case of array over here. So this is how array representation looks like. So with this, we have come to the end of this lecture. So in this lecture, we have learned how can we represent a binary tree using linked list, and how can we represent a binary tree using array. So in case of array, we are doing some mathematical calculations over here, and based on these calculations, we can find index of right and left subtrees. And here you don't need to forget that we are always keeping the first cell in case of array over here. So hopefully everything is clear about this lecture. Now let's continue to the next lecture. So see you in the next lecture.